Saxon Algebra 1, Lesson 21.
In this lesson, we study the product rule for exponents and addition of like terms with exponents.
The product rule for exponents.
Here's a question. What does x to the fifth times x to the third simplify to? To solve this problem, think of the meanings. X to the fifth means x times itself 5 times, and x to the third means x times itself 3 times. So x to the fifth times x to the third is x times itself 5 times x times itself 3 times. Well, you have a total of 8 x's being multiplied there. Notice that x to the fifth times x to the third is x to the 5 plus 3. The product rule for exponents, tells us that x to the m times x to the n is x to the m plus n, where m and n are real numbers, and x is not 0. In other words, when you multiply two numbers with the same base, you add the exponents. Here are some examples. Simplify 3 to the second times 3 to the third. The product rule tells us that's 3 to the 2 plus 3, so it's 3 to the fifth. 2 to the fifth times 2 to the seventh is 2 to the 5 plus 7, which is 2 to the 12th. A to the fourth times a squared is a to the 4 plus 2, so it's a to the 6th. P to the fifth times p to the third times p to the fourth is p to the 5 plus 3 plus 4, which is p to the 12th. Here's another question. What does x times x to the fifth simplify to? Again, we can solve it by looking at meanings. X times x to the fifth means x times 5x's multiplied. So you actually have 6x's multiplied, the red x and the 5 blue x's, so it's x to the 1 plus 5, or x to the 6th. This leads us to a definition. X to the 1 power can be defined as x. Here are some more examples. What is 3 to the 1 power? It's 3. What is 3 times 3 to the 7th? That's the same as 3 to the 1 times 3 to the 7th, and 1 plus 7 is 8, so it's 3 to the 8th. What's 2 to the p times 2? That's the same as 2 to the p times 2 to the 1, and so it's 2 to the p plus 1. Here's a slightly longer example. What's x squared, y squared, x fifth, y third? Well, it means x squared times x fifth times y second times y third. We put the variables in alphabetical order here so we can see what's going on. And then x squared times x to the fifth is x to the 7th, and y squared times y third is y to the 5th. So this expression can be simplified to x to the 7th times y to the 5th. Here's an even longer expression. M third pm xm squared x third p to the 5th. First, we will rewrite the variables in alphabetical order. So we have m third times m squared times p fifth times x third. And then we add the exponents. We get m to the 6th, p to the 6th, x to the 4th.
Addition of like terms with exponents.
When we multiply terms with exponents, we add the exponents. When we add terms with exponents, we do not add the exponents. For example, x third times x third is x to the sixth, because we add 3 plus 3. But x third plus x third is 2x third. Sort of like an apple plus an apple is 2 apples. So instead of adding the exponents, we add the terms the same way we add any like terms. When exponents are involved, like terms must have the same variables and the same number of each variable. For example, 4x third y squared and negative 9yx squared yx are like terms since each consists of 3 x's and 2 y's. The second term should be simplified. Negative 9yx squared yx is negative 9yxxyx, and then putting them in alphabetical order, negative 9xxxyy, which is negative 9x third y squared. Then if we add these like terms, we get 4x third y squared plus negative 9x third y squared equals negative 5x third y squared. On the other hand, 4x squared y third and negative 9y third x squared are not like terms and cannot be added. Though they contain the same variables, 4x squared y third has 2 x's and 3 y's, but negative 9y third x squared has 3 x's and 2 y's. Likewise, x third plus x squared cannot be added. They are not like terms. But those terms can be multiplied. X third times x squared is x to the 3 plus 2, which is x to the 5th. Here are some examples. Simplify. Add like terms where possible. Number 1, x squared y p fifth plus 2xy squared p fifth plus 3p fifth x squared y minus 7y squared x p fifth. Wow, this is kind of confusing because the variables are all jumbled up. So we will first rewrite each term so the variables are in alphabetical order. Then we have p fifth x squared y plus 2p fifth xy squared plus 3p fifth x squared y plus negative 7p fifth xy squared. We need to identify the like terms. The first and third terms are like terms, and the second and fourth terms are like terms. So now we add the like terms. The first and third terms add up to 4p fifth x squared y. You've got one of them and 3 of them. The second and fourth terms, we have 2 of them and negative 7 of them. 2 plus negative 7 is negative 5, so they add up to negative 5p fifth xy squared. And then we'll rewrite it without the plus minus there as ordinary subtraction. 4p fifth x squared y minus 5p fifth xy squared. Number 2, xy x fourth x third y fifth plus 2x third xy squared y fifth x seventh minus 5x eighth y to the 6th. Again, the terms are kind of a mess, so we will first simplify each term, placing the variables in alphabetical order. The first term has 8 x's multiplied, so it's x eighth, and it has 5 and 1. 6 y's multiplied, it's y to the 6th. So the first term is x eighth, y to the 6th. The second term has x third, x seventh, that's 3 and 1 is 4, plus 7 is 11, so it has 11 x's, and it has 2 and 5 is 7 y's, so we get 2x to the 11th, y to the 7th, and the third term is already simplified, negative 5x eighths, y to the 6th. Then we add the like terms. There are only 2 like terms, the x eighth, y 6th, and the negative 5x eighths, y to the 6th. So we add those, and then we add the other term. We have negative 4x eighth, y to the 6th, plus 2x to the 11th, y to the 7th. Number 3, 2x squared y plus 3yx squared plus x squared y squared minus x squared y minus 4x squared y squared. These terms are not as messy as in the last 2 examples, but we do need to place the variables of the second term in alphabetical order. So we have 2x squared y plus 3x squared y plus x squared y squared plus negative x squared y plus negative 4x squared y squared. Now we can add the like terms. The first, second, and fourth are like terms. So 2x squared y plus 3x squared y plus negative 1x squared y gives us 4x squared y. And the third and fifth are like terms. We add those. X squared y squared plus negative 4x squared y squared is negative 3x squared y squared. We'll just write it as subtraction here. This is the end of Lesson 21. Your assignment? Problem set 21 on pages 93 and 94 of your book.